Celery. The slides are online because I realised it might be hard for you guys to see in the back, so they're at bit.ly.com/celery to grab them. Yeah. So I'm Cameron. This is all my kind of web addresses. I'm a software developer at TrackMaven, and this talk is kind of what I've learned over the last 2.5 years using Celery there at TrackMaven. Everything from where we've grown from running 100 tasks in the background a day to a point now where we run around 25 million. So this is kind of split into two halves. In the first half, we're going to kind of go over what Celery is, what it actually does on the back end, how it kind of communicates across its entire stack. And then in the second half, we're going to kind of look more at using it practically. So what are some common patterns when you're building Celery tasks? How best can you tweak your stack to work with it? What are some things if you're starting to scale Celery that you need to watch out for? And just some intelligent decisions that will hopefully save you a lot of pain from things we've learned along the way. So before we get started, a quick survey. How many of you have heard what Celery actually is? Okay. How many of you have actually used Celery before? Okay, nice. So a lot of new Celery people. So until now, I've probably been talking absolute nonsense. So what is Celery? So Celery allows you to run units of work asynchronously. Now these units of work are something Celery refers to as tasks. Using Celery, you can add a task to a queue, and it will eventually be picked up and processed by a worker, all in the background. So the kind of asynchronous nature of it. Another interesting thing about Celery is these workers that actually do the work don't have to exist on the machine that produced the work to be done. So it enables you to distribute these workers across a cluster. And sort of as a task queue. So the work might not be processed straight away, but it will eventually be queued up and hopefully consumed and performed down the line. So what's an example of this? One of the common use cases of this is when you're building web frameworks, or when you're building websites, sorry. So with a website, the kind of idea is you want to get a request and you want to shoot back a response as soon as possible. If you have the scenario where maybe you have a new user signing up for your website, you want it that after they sign up, you send them a welcome email. Now, if this happens inside of this request-response cycle, they might send back their form to your web server, and then it has to go off to the SMTP, or maybe you're using a HTTP API to send out your email, and that should take a couple of seconds before it follows through and gets sent out. Even worse, if that API is down to send out your emails, then the web response will return an error, and that's something maybe you don't want to happen. So a better way to do this would be to have that welcome email be sent in the background. That way you can just tell it to queue up, and if something goes wrong, you can have additional handling for it while it's running in the background. And you can get a response back to your user as soon as possible to let them know that they've signed up. More examples of this, maybe you have very computationally heavy jobs that you use a lot of database queries, or really slow database queries, or they do a lot of maths, that you want to kind of run in the background and cache the results for when people come to view your website. Maybe you're interacting with external APIs and you kind of periodically want to pull data from them. This is also something you want to run in the background. Or maybe you just want to do anything that runs on a recurring basis. So maybe you want to have a job that's run every hour, every week, at Sunday at 3 a.m., some sort of periodic job that you need run. And Celery is all kind of designed to handle these use cases of running things in the background. So a brief history about Celery. It's all written in Python. It was first released about 5 years ago, in 2009. It's currently on version 3.1, and it's developed mainly by one person. So it's been quite an interesting project of how it's changed over the years. Before, it was very closely tied to Django. So you shouldn't really, having Celery run without Django wasn't really the easiest thing to do, but it's made big strides with the recent versions to become way more agnostic. So it doesn't rely on having a web framework to support it. You can run Celery by itself, and that will be kind of the examples I run through in a bit, which is kind of a very good change, but it also has a lot of integrations for very popular Python web frameworks out there, such as Flask and Django, and other ones as well. So, this is going to be hard to see. So, I want to show you how Celery actually goes about sending a bit of work and how it kind of navigates the Celery stack. So, there's 4 main stages here. The first being the producer, it then goes to the broker, and then goes to one of several workers, and then it goes to a result backend. But what do I mean by each one of those stages? So a producer is a real simple concept of it's just something that produces a job or a task for the queue to do. So this should be anything. So in our example before, when we wanted to send out an email, that should be triggered by the user, for example, or by any other web request. It should be triggered by our own system, so maybe we want to have something run on a recurring basis. Maybe we send out a management command to our server, just something that says it wants work to be done. The broker is the next part of this. It kind of answers the question of what work remains to be done. So a broker records the task that the producer wants to be run through a message system. So you might have a flood of tasks come in. It might be a case of 1,000 users all signed up at once, and you want to send out 1,000 emails. That might take a bit of a while to get through. The broker is what stores these in a kind of task queue so that it can eventually be consumed by workers. So workers do the actual work you want done. An important thing to note is in this diagram here, you kind of notice there's one broker, but there can be many workers. So you can kind of distribute it out there and kind of get this horizontal scalability of having more workers than there are brokers to kind of consume tasks, hopefully faster than what they're coming in. And then finally, after you've done this work, you might want to store the results of that. And Celery gives you a lot of options on how you can store the results, but this is kind of an optional stage that you don't actually need to use too often with Celery. It really depends on the application you're doing, and I'll show you some examples which will maybe make that a little bit clearer. Okay, so that's the kind of theoretics of it. How does this actually look in practice? So this is a Celery task. I'm going to actually try and zoom in here because I think this is a little bit too small. Ooh. Okay. Is that any better?
Yep.
Okay. So this is a real basic Celery task. You see here we've imported Celery in. And what we're going to first do is initiate the Celery object. So I've given it the name of task, and I've pointed it towards the 2 other components in our stack. So that's the backend, in this case Redis, which is going to store the results we get out, and the broker, which is Rabbit and Queue, and I'm just pointing it that way. Essentially, I've declared a real simple function that adds 2 numbers together and returns the result. And at the top, I've kind of put this decorator that says app.task. And what this does behind the scenes, I'm going to show you how this kind of transforms it. This turns this function into a Celery task, which gives us a lot more methods that allow us to run it asynchronously. So after this has happened, what I need to do is, with Celery installed, I'll go in and I'll start my worker running on a separate process. So I've told Celery, okay, Celery, I want you to run. I'm pointing it towards my application, so in this case that capital A file is what refers to this app.py here. And I tell it I want you to be a worker, and I want you to put your login onto info. And then I'm going to show you the clip above soon. And what this allows me to do is now my new function that's been converted to a Celery task, I have a bunch more methods on it that I can kind of call for it to trigger. So instead of calling it straight as a function, it now has this method called .delay. So I can pass that the 2 arguments, 4 and 4, which should add up to get 8. And what it returns, instead of returning the integer result straight away, it actually returns a Celery result. And the Celery result has a lot of information stored about it. It kind of says, has this task successfully managed to run as the state? What is the ID of this task? And that kind of maps up to where it is on the broker. And then finally, I can call get, which will wait until this result is processed by my worker and then sent back, and it will show the return from that task. So, let me see if I can find my mouse. So this is it happening in practice. On the terminal on your left, I'll be running the worker. And over here, I just have a Python shell where I'm going in and I'm going to run the task 2 times. So hopefully this works. Maybe. It should be local. Let's have a quick refresh. No. Okay. You have to believe me that it actually runs. So sorry about that. Hopefully that'll be on the slides when they go online. Ooh. Actually, I might just try and run it from here.
Give them credit, ladies and gentlemen. This is a live demo.
I even recorded it just to avoid this. Okay, here we go. So yeah, here will be the worker, and on
I'm
there
a liar,
will
it's
be
not a live
the... So I'm starting the worker up, and it gives me this whole lot of login information about it. Now I'm going to import the function before, and I'm calling that .delay function with 2 arguments to add together. And you can kind of see over here, it says that the task successfully ran, tells me how fast it ran in, and then over here it says the result that came back. And over here I have access to that information I showed you before. I can do the get of what the actual result is. So you can see everything kind of playing together nicely. And as mentioned before, as long as, here I'm running these both locally, but I could run this worker anywhere as long as it had access to the results backend and the broker. As long as when I ran this in my shell, I also had access to the same broker. So it can be distributed across the cluster fairly easily. All right, back to that. Cool. So I mentioned before this app.task decorator kind of transforms your function behind the scenes. So Celery gives you a lot of options on how you want to declare and run things, and maybe I have a few more examples of where that becomes apparent later on in the task. So what this is doing behind the scenes is transforming it into a Celery object, task object, where it's moved the logic from the function before into this method inside called run. So the kind of equivalent here, I can still call the function as I'd like to normally, but if I wanted to, I could also call it, I could also write it in this way if you prefer class-based programming, or it works better for your application. There's no real benefits or downsides to writing it either way. It's kind of your personal pick for what you want to do. But using the app decorator transforms it to this behind the scenes. Likewise with declaring tasks, Celery gives you a lot of options on how you can actually run them as well. So before I showed you the .delay method, which allows you to pass the same arguments you had, there's also apply async, which allows you to pass a lot more customizable variables. So I'm still passing the arguments now as an argument, but I can pass specific runtime parameters in there. So this cooldown says I want you to run in 500 seconds. This expiry says if you don't run after 1,000 seconds, don't even bother to run. And there's even more options in this. You can run .apply, which executes it locally. It doesn't actually go out and run on a worker, and it blocks until this actually goes through and runs. But it returns a Celery result nonetheless. Secondly, I can run it just as a normal function if I use the thing before, which is kind of useful if you're trying to test these. So Celery doesn't stop you having access to the functions you wrote in the beginning. Cool. So that's kind of an introduction on how you write a Celery task. Let's look at some best practices when you're trying to write these in the real world. So, first things first is you want to try and keep your tasks as granular as possible. The reason for this is it's easier to scale up Celery so you can process more in parallel. So, here's an example of 2 different tasks and 2 different approaches you can kind of take. So in the first task, what I'm doing is I'm getting a post out of my database, and then I want to run a bunch of stuff on it. So I want to run language detection, I want to extract some topics, and I want to get some shared data, like how many times it's been retweeted or anything like that. So in the first, this task does everything. I get the post on my database, I go ahead and run all of them, one after the other, and that's the entire thing. With Celery, you can easily break up these different components into different tasks themselves. So here, where I want to update my post, instead I'm saying, hey, go run language detection, but run it as a task. Do topic extraction, but run it as a task. And do the shared data, but run it as a separate task. And if you design your tasks in such a way that they don't rely on each other, and I'll show you an example of how to structure your tasks if they do rely on each other, this is kind of a good way to squeeze out performance and make sure your tasks run as fast as possible. What's neat about this is maybe language detection requires a lot of CPU to process, but shared data is real network bound. I did have workers on different machines where one was way more CPU powerful, where I should run my language detection task, but then on a lighter machine which has better networking options, I should run the shared data stuff and really optimize and try and get the most out of my task. Also, a nice thing about this is if one of these fails while running through, you don't necessarily have to start the entire task and operation again. So building your task with some resilience in, and I'll show you in more detail how you retry tasks and deal with errors, is kind of a good idea when dealing with things that run in the background.
Okay. Sorry, is it okay if I ask now?
Sure.
So in the second example, is the decorator like super decorating, or was topic extraction already decorated elsewhere?
That's a good question. So each one of these would have to have their own decorator and declared as a task in the same manner throughout. It doesn't kind of, it can't sort of supersede itself and like tell all the functions inside that you should be tasked now. Yeah.
Cool.
Cool. So that's one of the tips. Another one is be careful when passing objects in as arguments, especially if they're database objects. So in this task, I kind of have an example where I'm passing a Django ORM type object through that kind of maps out to a reminder maybe that a user's created on our database. In the first, I just pass the database object straight through, and it sends out an email to remind that user. In the second, it actually goes ahead and I pass in the primary key, and I look it up there locally before proceeding and sending out the mail itself. So there's two kind of things that can catch you out with sending the database object or any object as an argument to a task. The first is it can add a lot of overhead to the broker. All the arguments that are passed as Celery tasks need to be pickled in and included in the message, and sending a PK in this example, which is just an integer, is a lot more lightweight on the system than sending a reminder. The second thing is state can be quite tricky to do in a distributed system like Celery. So for example, if the user had set this out and they said they wanted to run in an hour's time, maybe they cancelled it and deleted the actual database object and we don't want to send it out anymore. Maybe they updated the note on the reminder, but all of that wouldn't necessarily come through in the first example because it kind of has the same data from when it's being sent out and pickled at that time. So building your tasks to not rely on database objects as arguments is kind of a good idea, just to kind of keep state as simple as possible. There are some use cases, and it really does depend on your application if you want to send database objects as arguments. It's only the case if this lookup does incur a cost to actually look out and reach out to the database. So maybe if you're fine-tuning things and you want to really iron out some more throughput, then it makes sense to sacrifice that safe state. But it really depends on the application. And generally, you want to try to avoid doing this because it can produce a lot of unexpected results. Another thing you want to do is if you have tasks that rely on other tasks, you want to try to avoid tasks launching synchronous subtasks. So in this case, I have something that goes ahead and fetches some data from a page, and it has 3 different processing things which, unlike the example before, they kind of all rely on one another. So in the first, I download it, then I pass it, and then I store the page info. So when we're running through here, it gets the result, waits for it to process, and then goes on to the next. The problem with this is you can get very quickly into a deadlock situation. So if, for example, your worker could only process 2 tasks at a time, and then 2 of these were queued up instantly, they both reach this state and ask the worker to then process fetching the page. There's no available space for the worker to do any more work, so it's kind of stuck here, kind of waiting indefinitely. But Celery kind of built this in mind, and they have these things called primitives that allow you to work around it. This is one of the primitives. It's the chain primitive. Basically what it does is the result of the task is passed to the argument of the next task. So if you have interdependent tasks, these are a better idea to kind of chain them together to make them work better and avoid that deadlock scenario. Next up, you have periodic tasks. So these are the tasks you want to run on a recurrent basis. Now, like before, Celery gives you a lot of ways to run these. You can use them as the decorator above, but you use periodic_task now. And you're also required to pass a run every argument into it. So in this case, I have a time delta for 5 minutes. I can also do this as a class-based thing, and here I just pop it on here with my run every argument. That's another way to write it. There's also a third option where you just write it as a task, but instead you include a setting which Celery has to discover, and I'll show you how to do that in a sec. That includes the schedule, and you can keep it as a normal task as you are. So there's no real benefits or downsides to each one of them. It's kind of a preferential thing and what fits into your project. So you have the time delta that runs every 5 minutes. You can also do it cron style if you want. So here you can have it run every 3 hours, every minute on Sunday, every first month of the quarter. One thing to watch out for this, if you haven't used cron before, is if you miss out and don't include the minutes argument as 0 or some sort of value, it will run every minute or every hour. So it's just something to keep in mind that might catch you out and have you run a lot of tasks all at once. So a kind of common pattern to do with this is to have these reoccurring tasks spawn off and send out loads of tasks relating to a kind of group of things. So in this case, I have where I want to send out a daily email to my users. I get all my users out of my database, get their IDs, and then I go ahead and forward and send these out to these subtasks, calling this delay thing here, to go ahead and run and send out a nice email reminder. So here you can kind of see 2 practices built together. I didn't pass in the user object, instead I've told it to look up the user object when it gets to here. And also here I've built in a kind of a fail-safe in case things go wrong. So it's hard to see, but what it does here is it checks, have I sent an email out already to the users? If so, don't send anything out. Otherwise, let's spam them and tell them not to forget to log in for today. So building your tasks as if they're going to be rerun in mind is often useful for the case when things go wrong. So maybe this failed to send halfway through. In that case, I can just run scheduled emails again, and all the users that have tasks already set for them, or already have emails sent out for them, I'll know about, and I don't have to worry about balancing out and figuring out who got an email and who didn't. If you want to do this, you need to add another little component to your stack, and this is the beat. So before I showed you how to run a worker, instead here you need to run a Celery beat, which does the scheduling. And with these, it's generally a good idea you can share a single process that is both a worker and a beat using this capital B flag, but it's generally not a very good idea to do. You want to make sure, and this is kind of one of the, I've heard quite a criticism of Celery, you can only run one Celery beat at a time. Because of this, if that Celery beat goes down or that machine goes down, tasks will stop scheduling. So it's kind of important, if possible, to avoid all the implications that could cause it to go down. In this case, maybe running additional tasks on the machine that is also the scheduler is a way to avoid that. Another thing is, if you run duplicate beats, they will schedule as many tasks as they are, so be very careful with that when deploying stuff out. You also need to be kind of wary with frequently running periodic tasks of this idea of task stacking. So imagine a scenario where we have a task run every 5 minutes, and the tasks that are produced by that take 30 minutes to run, and we're just on one worker here. We're going to get to a point where the tasks start to stack. So the scheduled tasks can't run instantly, they're just told to run at a time, and they'll wait to be run until there is a bandwidth available from the workers to run. So we'll have a case where after 30 minutes, we'll have a scheduled task run, the beat will tell, hey, you need to run this task 5 times to reschedule things, and all of a sudden, 5 scheduled tasks will all run at the same time, and you'll get this sort of problem compounded over again, and before you know it, your task queue has exploded. But there's ways to prevent this with Celery. So I showed you off before the expiries flag. You can add these to the decorator of tasks, and they basically say, if I don't run after this amount of seconds, don't run at all. So with my scheduled task that runs every 5 minutes, if I expire it after 5 minutes, then by the time it gets to that situation where it's been 5 minutes, hasn't run, it doesn't really matter. I know there'll be another one running in 5 minutes, and I've kind of prevented a task runaway scenario. Likewise, you can apply the same to your repeating subtask below. If it expires after 5 minutes, then it kind of keeps it in control if things are running slow for one day. And things don't run in tasks. The kind of general strategy you want to do is, what should I do when things go wrong? So here we're gathering some data from the API, and maybe we're rate limited. In this case, we can raise a Celery exception called retry, and what this will do is it will rerun the task depending on the variable we've set above here, max retries, a certain amount of times again. So here this says retry this in when is a number of seconds when to do it, and retry it 10 times throughout. And if after 10 times it doesn't go through, just give up. Also below, if the API is down, or there's some sort of scenario where retrying doesn't make sense, a kind of quick way to get out of it is just return out of the task, and just be done with it. And hopefully, when it comes to the next run again, the API or whatever you're relying on that is down will be back up. It's also kind of hard when you have all these things running in the background to know when stuff is going wrong. So having some sort of error insight is very useful. We use a tool called Celery, which gives you insight into all the stuff that's going wrong, and it's kind of useful just for keeping track of all that different stuff. Century, sorry. So Celery gives you a bunch of different options you can run on tasks. You can run abstract tasks, which as they just sort of should have a bunch of methods on that you use further on in your task. If you want to have that kind of dry repeatability to it, kind of depends on your application if this makes sense to do. One interesting thing about Celery tasks is they're only instantiated once per each thread. So what this allows you to do is, if you have a task, you can add very cheap and easy connection pooling on the Python side. Because this is only initiated once, after my database is declared, it will be shared amongst all other database tasks. Using together with this abstract task is kind of a useful feature to know. There's also more advanced things you can do. I'm going to skip over this now, but to read on the slides. If you have an application where you only want one task to run at one time, there's kind of some common patterns here using a cache to kind of lock out tasks from running until it is cleared. So as I mentioned before, with Celery you can apply some certain settings. So different ways to do this, and it kind of depends on the integration you're running with. So here's a kind of one way you can do it. Pass into the app itself and update these various settings. Another one is you can point Celery to a different file. They traditionally use Celery config and have the settings in there, and it will import them all in like that. Some important settings to note, because there's a lot of settings out there. These ones here. So you can ignore results. So in the examples before where we were sending out the emails, we weren't necessarily concerned with what the task returned at the end. We were more interested in manipulating the database objects. So ignoring results, if you're not using them, is a great way to decrease or increase the performance of Celery as you just cut a component out of your stack. It's generally a good idea to set a soft time limit and a hard time limit, which is just called a task time limit. This kind of says if the task hasn't run after X amount of seconds, first raise a soft time limit exception error, and if it hasn't run after so many other seconds, exit the task out. This kind of stops your task queue from stalling out and keeps it rolling throughout. You can also pass these in as arguments above the task. So again, Celery gives you options on how you want to declare these things. If you're looking at scaling things, these would be my suggestions of 2 settings to check out first off. The first is max tasks per child, and this is the maximum amount of tasks a worker should run before it kind of restarts itself. This is very useful if you're dependent on other libraries that might have memory leaks and you kind of need a clean slate to stop it getting out of control. Otherwise, the other one is a prefetch multiplier. So each time the worker needs to go and get tasks to do, this kind of decides how many tasks should I take on to do at a time. So if you're running a lot of really short duration tasks at a time, you can pluck out many of them and kind of save that network bandwidth of having to go back and forth to get new tasks to do over time. And it kind of depends on your application. If you have longer running tasks, this doesn't matter. So these are the kind of ones to mess around with when trying to scale up your application to see if they have an effect. Cool, so onto the broker. So Celery gives you loads of choices of what you can use your broker to be. If you were using Django, you can use Django's own ORM as both the broker and to restore results on the back end. So this is kind of neat if you're using Django and you don't want to add another component to your stack, and maybe it's kind of your own personal site. Celery lets you do that, and Postgres or whatever you use can deal with the transport needs of that. But don't do this for anything serious. The broker actually does a lot of work in the background, and my advice to you would be to use RabbitMQ. The guide developing Celery also works for RabbitMQ, and you kind of see this coming through with how its support is kind of better than the rest from what we found from experience. Redis is a close second, but RabbitMQ offers really good task acknowledgement. And by that I mean, once a task is actually queued up, if something goes wrong with that worker, maybe you're restarting your server to deploy a new version, or it exits non-gracefully, RabbitMQ has good handling for putting that task back in the queue and having it run again. Redis can do this as well, but it does it through an emulation layer. It basically works by saying, okay, I'm going to send this task out to my worker, and I expect a signal back within a certain time frame, by default an hour. If I don't get that signal back within that hour, I'm going to assume the task failed and rerun it. So in the case where I gracefully exit out, that task to be lost, but it will take Redis up to an hour to realize that has happened. And if you have really long-running tasks, you could have set it also longer, and it kind of gets harder to manage. This gist here does a really interesting job kind of exploring what's happening behind the scenes, so if you're interested in that kind of stuff, that's kind of neat to check out. But my main advice is use RabbitMQ. It also offers a lot more monitoring tools, which I'll go over in a sec, that make it kind of a nice choice. And if you are using RabbitMQ, you can install this C-optimized library for it, which will just give you a free performance boost, and it's incredibly stable, which is always nice. So with workers, you can tune your workers to run at a different concurrency. So each worker is a process, and each unit of concurrency is a thread. There's more advanced concurrency methods. I think gevent is one of them. I haven't dived into them in too much depth. The Celery documentation does a decent job going over what they do. So here, if I wanted to increase the concurrency of one worker, I can just use the capital C flag. Also, Celery gives you an auto-scale option. This kind of says cover between the minimum of 1 concurrency and 10 concurrency based on the kind of task back queue. So it's kind of a neat way to auto-scale up your tasks without having to put too much logic in yourself. One of the first things you'll notice, what we noticed when using this with the web framework, is the increased concurrency can quickly drain connections on your database or any other data store. So generally, as you start to run more and more tasks, use a connection pooler. It's one of the first things you'll run into, and it's kind of worth watching out for and keeping in mind. Routing. So each task can be routed to a different worker. For example, if you want to send out emails, you might want to not wait until you've run other tasks. You want to send those out as soon as possible. Celery allows you to do this again in like 2 different ways. The first is you have the Celery routes, which is on your settings discovery path, and you say, hey, for this task at this path, I want you to point it towards this queue. You can also apply it with the apply async option, which if you the ability to declare the queue at runtime, which is kind of useful maybe if you want to route to different queues depending on certain variables then and there. And when you run your worker, all you need to do is tell it that, hey, I'm running this queue, I'm going to be the capital Q flag, and you're the priority worker. You can have multiple queues for each worker. So you can have Celery. By default, Celery uses a queue called Celery. But you have work to do multiple or single queues. It's a good idea to dedicate your workers as well. Don't make them do too many things. Ideally, you want this to possibly be reflected across your hardware as well. If you have like for the example I said before, maybe you have tasks that are more CPU intensive, maybe you have tasks that are more network intensive. Having workers on different machines that optimize themselves depending on what they're actually doing is kind of a good idea when you're starting to scale out. Doesn't matter so much at the beginning, but it's kind of a more robust way. As well as if a worker goes down, if you had a worker that was doing all the different tasks in one, if that goes down, that could stop all the tasks, whereas it's probably better if it just stopped the queue it's doing to minimize the damage. If you're running into bottlenecks, the best thing you can do is really identify what they are, fix what they are, and kind of repeat this process over and over again until you've got the performance you want. With Celery, there's two different ways to do this. You can make your tasks faster, or maybe you need to reduce the volume of tasks you're running. New Relic is a good tool for doing this. Again, Screenshot hasn't loaded, unfortunately. But what it does is it not only gives you insight into viewing the number of tasks you're running, but it also lets you break down what's actually slow in each task. So here's a kind of breakdown of different database queries and the average time for them, so I kind of know where to start to begin to attack, where is the slowness in this task, and handling that. So monitoring is really vital when running Celery. RabbitMQ has a great management plugin that comes with it. It lets you see how many tasks are in your backlog, what rate are they getting processed at. It also has a really good HTTP API. So one of the things we did is we used this to write our own monitoring tool and plugged it into Vibrato, which is a graphing tool. What this allows you to do is you can see not only your task queue over time, how it's changing. You can also use Celery to see how your workers are, how they're staying up, how they're dealing with it. And I've included a gist in the slides if you want to check it out and maybe use it in your stack. Also Celery Flower, again, Screenshot hasn't loaded, unfortunately. This is a good option. I haven't really checked it out, but I've heard good things from people who've used it. So that's it. That's kind of everything in a nutshell. Thanks for listening. Any sort of questions?
So you talked about rate limiting tasks. If you have, say, an API that, say, limits the rate that you can query it, is there some way of backing up on all tasks, or can you just do it on a single task?
Celery gives you, one of the options Celery gives you is a rate limit argument, where you can tell it you want to run so many tasks a second or a minute. The problem with that, though, is it's very hard to have that applied globally. That will apply for each work process in each queue, but it won't apply across your entire cluster. So generally what you need to do with that, unfortunately, is kind of write your own solution. So maybe that's writing with Redis, kind of a real simple key value store to keep track of how many tasks you're running per minute. But if you're running a real simple Celery process with one worker, one queue, and you know that's not going to be repeated anywhere else, the rate limit option is maybe useful for that. But it's not the ideal solution. You kind of have to roll your own, unfortunately.
But, sorry, so,
Sure.
so if it was something that maybe you have lots of tasks but only one for this rate limit thing, you could just have one worker, and then that would be enough, right?
It kind of, I haven't really dived into, from my understanding, how the rate limit works is it will say, okay, across these 10 seconds, I can only, across a minute, I can only run 10 tasks. So it might run all those tasks right at the start. So if you're in the case where you're running just a simple worker and a simple queue, and that kind of paradigm works for you, for the API you want, then I think it should be appropriate. Yeah.
I will try.
Cool.
So, like, you talked about when sometimes the tasks will error out, and a good way of doing that is just, you return out of the task.
Mhm.
But is there an easy way besides just telling it to retry, if like your API goes down and then you realize the next day, is there a way to grab all the things that have failed recently and just say, okay, restart those, put them back in the queue?
Sure. So in the example, I raised a Celery retry error. If you raise another exception, Celery doesn't automatically retry on any other exception. So maybe one thing you could do is raise a bunch of exceptions that say stuff is down, it lets it out not very gracefully, but then you could see in your error monitoring tool that, oh, a bunch of tasks errored out with this error yesterday evening or whatever.
And it's easier to just pick those things up and then put them back in, like once they're logged, but like, can you restart them at that point?
Oh, so you're talking about retrying the task if it's failed until it's kind of succeeded.
Precisely.
Yeah. So with retry, you can do that. You can retry a task indefinitely. It's not a good idea to kind of say retry until you pass, just because if it gets rescheduled or anything, you can kind of have them both running at the same time. But it kind of depends on the retry strategy. So, for example, a reasonable thing to do maybe is you want to retry it for the next 12 hours. This is a daily task that you run once a day, and it's kind of vital that it goes through. So you're okay with retrying it once an hour, and that's a Celery setting you can set, and 12 times. So it'll retry 12 times over a 12-hour period. So you can kind of make it relentless in retrying like that, but it's up to you and kind of depends on the application you're running. But it does give you some options to kind of do its best to succeed at the time. Sure.
Can you run multi-threaded tasks in there?
Sorry?
Like multi-threaded, synchronously, like doing asynchronous tasks, but in multiple threads?
You'd need to. I think Celery doesn't give you the I don't know of any option that allows you to kind of mix asynchronous and your own threads. I think you'd need to kind of write your own at that point. But I haven't come across any examples of using Celery to do something like that, unfortunately. Sure.
What are some good use cases for using something like the heartbeat service instead of more specialized library for that, like a UG or a Chronos kind of external comment?
That's a good question. I haven't come across any of those other libraries. I guess Celery is kind of very easy to kind of implement, and from what you've seen from the examples there, you can kind of just write Python functions that you're used to and kind of get up on the ground very quickly, and all you need to do is slap this decorator on top, and you can kind of get moving faster. I think I've seen Luigi before, and it kind of forces you to change how you write tasks, or write jobs, am I right in thinking? So I think one of Celery's great strengths is it's very easy to get off the ground and running, whereas maybe with some more advanced libraries that maybe result in better throughput down the line, they require a much more configurable approach, which is kind of a trade-off.
Related question.
Sure.
What other, if you weren't going to use Celery, what are other options that are similar maybe?
So there's a lot of